Hello, everybody, and welcome to our May Data Science Code Pudding live stream. My name is Tiffany Hall. I'm an alumni of TripleTen Software Engineering Program. I'm a full stack engineer, and I'm a product owner at Scholastic Inc., the world's largest publisher of children's books and a powerhouse in the digital education space as well. Thank you again for joining. Tonight is one of my favorite things to do, which is to be a host of our code puddings and code jams at TripleTen. I'm really excited to see how many of you could join us and how many of you are watching at home. So hello to all of you at home. Um, the best part about the code puddings, I think, is that it is a wonderful opportunity for our students in TripleTen to be able to practice working together across time zones, all across the US. If you're new to this space, you might be asking yourself, what is a code pudding? So, a code pudding is a friendly competition at TripleTen where it's super short, very compressed time frames, where our students are completing an extra project essentially during their normal coursework. Very super short timelines, about 4 to 5 days each. And then our students get together as a group and they start putting in the work on the competition prompt. Since these are so short, this one's like a little dessert. So it's kind of like a pudding. All right, our code pudding consists of two parts. We have the working with the data and building the model and the presentation. So data, model, presentation. Last week, our participants were divided into teams and challenged to collaboratively build a machine learning model to detect bias in Wikipedia articles based on their language and structure. And I don't know about y'all, but boy, is this the time to have this project. So our teams had 5 days to work on it, and tonight we get to see all of their projects. They're going to show them all off to you out there watching in YouTube land. And then in the next week, our judges are going to review them and evaluate them on both the model and the presentation. All of our results are going to be posted in our Discord and our socials on May 14th. If you would like to vote for your favorite, being that you are an audience member, you can go ahead and, if you're a student, you can vote for your favorite team in the Discord channel. You'll see a poll there after this stream. And if you're not a student of ours just yet, you can go ahead and either vote in the live chat below me, or you can vote, if you're watching this on replay, you can vote in the comment section. Okay, now it is time for my favorite part where we get to see all of the nerdy little details that our students have put together and just kind of bask in all of the data goodness. Our first team for the evening is going to be Fine Print. And this team has the students Gil Fadu, Tirso Paneke, and Julia Porino.
Hi, everyone. Thank you so much for coming. I'm hoping you're able to see my screen. We're excited as a team Fine Print to present our project about bias in Wikipedia for the May 2025 code pudding. First, a small team introduction. Jill Faldu, Tirso Paneke, and myself, Julia Prino, worked on this together. We're all part of the TripleTen ecosystem, and two of us have graduated. Wikipedia is a crowdsourced of information. Cyber radicalization has become more and more common. In our desire to help the platform and readers spot bias at scale, we want to detect and quantify bias in an article. To do so, we're going to find an article data source to train our model, build that model, and then use that model to predict bias in a new article. We want to focus on these questions. How can we define and detect bias in Wikipedia articles using machine learning? Can we train a model to reliably distinguish between biased and neutral language? And how can we apply this model to assess the overall bias of an unseen Wikipedia article? We want to start by defining what bias is. Bias most often is just a word that attempts to influence the audience by using an appeal to emotion or stereotypes. On the right are some of the examples of words that tend to elicit emotion. How does this affect us in real life? We see there's a study from the Manhattan Institute that shows how the news reported on US senators. They could have either had positive or negative language. It's clear from the colors and the way that the graphs go that on the left, the Republicans tend to be described with negatively biased language, and then the Democrats on the right have positive language. This lack of neutral language could really have an effect.
So before we started the project, let's look at the data set. So we got the data set from Kaggle website of Bay Media Bias Annotation, which had around 3, 6, 7, 4 sentences labeled by expert as biased and unbiased at both the word and sentence level. It also covers various topics in fairly balanced manner. Next, please. After choosing the data set, we did an so for processing we find some missing in costs and there were no duplicate. We combined the text data standardized column values to lowercase it, removed unnecessary characters from the biased words column, and simplified topics by removing hyphens and common stop words. Following this, next please. Thank you. Following this, we also started cleaning our text column and lemmatizing it. So for cleaning, we applied our text cleaning function to standardize and simplify the data. After cleaning the text, we took an extra step to further simplify the text by applying lemmatization, which reduces each word to its base or root form known as lemma. After we are done with cleaning and lemmatizing it, we started reviewing to our questions to better understand our data set and know the relationship between. So the first question we asked was which topics has the most biased words on average per article. We found that topics like the Trump presidency and white nationalism tends to have the highest average bias on the graph on the right side, while topics like immigration and universal health care shows much lower levels. The likely objective behind the higher bias is to sway opinion through unsubstantiated or emotionally charged claims. Question we were discussing over was which words are most frequently used across the data set. For this, as you guys can we noticed that words like legal aliens are as biased. It shows how emotionally charged of underlying bias in news report. You guys can also see that first three words like we'll talk about question 3.
Sometimes bias could be more than just a word. The writing tone or a sentence could also show bias. The data set that we examined included a rating for sentences that were their ability to evoke a mental picture and for how tangible the ideas are. Those two have an inverse relationship. If words in a sentence have low tangibility and high ability to evoke a mental picture, it tends to be more persuasive or strong language. So this graph shows the polarity between biased and unbiased articles as determined previously in the data set. We show that biased articles tend to have more extreme and a wider spread of both positive and negative sentiments. We also wondered which news outlet is the least biased. The alternate and Federalist on the left have strong ideological views, and at 0.7 had the highest amount of bias. MSNBC and Fox News on the right are on political ends of the spectrum, but actually report with a similar bias metric. And we found that Reuters was the most trustworthy by not having a lot of bias. We also had concern that is the data set balanced between biased and unbiased data rows? We didn't want this to affect the results of our models, so we ran a quick check test and it showed that the data set is nearly balanced with a slightly higher number of unbiased sentences compared to biased ones. We also we needed to do some manipulation with the text, we use TF-IDF to convert text into numeric vectors that the model could understand. The code on the bottom shows a portion of this being used to convert the data set before the model could read it. And we really wanted to establish the target of our model was really determining if a bias exists or not in a sentence and then an article at large. Here we have some examples from our data set. In the first sentence, we see their word flagged is cult. And so based on the fact that there is a biased word inside the sentence, it receives a Boolean value of 1 for true that it is biased.
Julia, who are we waiting on?
She was right there, but I'm like, did something happen with her computer or anything? I don't want to
It
click off.
looks like she might have dropped off the call by accident.
Okay, cool.
It's
That's
how it
okay.
goes.
I'm hoping that she'll jump back on and be able to help finish out. But we compared several different types of machine learning models, logistic regression, random forest classifier, XGB classifier, light GBM classifier, and created a neural network. We can see on how they scored on their training data set. And we see the neural network and the logistic regression were both pretty close together. One was 0.76 and one was 0.71. So we chose to evaluate the randomized article with both of these and see how they compared since they were so close. The randomly selected article ended up being the 2024 United States presidential election. You can see a screenshot of the article below. And here's some code screenshots of what we used to get that random article to evaluate. When we evaluated with a neural network, the first thing we did in building that network was have a BERT processing of sentence. This is actually a language model designed to understand the context of words in a sentence that creates a string of numeric values that enables the model to grasp meaning, nuance, and then relationships between words. Again, not just a single word that is a bias, but overall. We had 3 layers of neurons with a 30% dropout between layers. And so we started out at 512, went down to 256, and went down to 1 to get our results. We can see from the results on the right about the distribution per sentence inside the article that there's varying degrees of bias in each sentence as it goes along. It does seem, but overall there is 64% of the article has some bias registered in it. But we can see the degree of what it's rated changes.
Julia, it looks like Jill was able to join back in.
Cool. She'll love to get to do this slide.
Okay, so another model which we tried for looking for our bias score for the random article we got from Wikipedia was IFIDF and logistic regression. So as you guys can see on the graph, there is a for both of them.
Next slide, or did she happen to drop off?
Like
Okay.
Julia.
Okay. All right. Thank you so very much. So
Um,
sorry, I had a little bit of a delay there.
yeah, there's just, can I do the conclusion if she's not available?
Please jump on in.
Okay, sorry. I know there
No,
seems to be some
no.
technical issues, but our overall conclusion was that data prep was everything in helping to prepare and make a good model, but also that bias can be really subtle. Even in neutral sounding arguments, we found cases of bias. But neural network proved to be the best in evaluating this sense of bias. There was some limitations in the model that we created. We did not have access to some other dimensions like cultural bias or structural bias because of the time constraints. So the model is not perfect. In the future, we would hope to expand the data set with more articles that have longer text to be able to evaluate those other types of bias, like cultural. We would also tend to weigh higher bias words so that they count for more. And we also feel it would be a great idea to have this integration of a bias checking Chrome extension inside. But fine print says thank you for your attention.
All right. Thank you so much. I really, really loved the steps you guys showed about the cleaning, especially because you mentioned at the end, like it's really important that the cleaning part was the reason you guys were able to get the results you were able to get, and showing, I think, myself, but also the viewers at home, that what it looks like originally versus that first kind of layer of cleaning and then the next layer of cleaning. How long does that take you guys as a team to work through all of those data sets?
Well, we actually had some fun team cooperation and great communication from Jill herself. Sad that she is having tech issues, but maybe the cleaning of the data took, we met on a Thursday, and then by Friday night, it was pretty done.
That's amazing. Now, Tier, so this is not your first go around. How is it this time around for you?
As usual, nervous of public speaking,
Yeah.
but hope to get into another one. It's really
Did you feel
fun.
like that it was better this time around in terms of, your nerves around working with teammates?
Uh, Pretty much the same. I'm not gonna
Okay,
lie.
that's okay.
You can
No, I
never tell. He's
appreciate it.
a great teammate.
Oh, that's the thing. I always try to remind him and a lot of the others that join, and they feel a lot of those nerves. It's totally normal. But I appreciate your courage in keeping coming back, and you keep having a high bar of being a really great teammate. So I never have nerves for you. Um, let's see. One more question, just kind of around the the pieces of the what articles you guys decided to focus on. Did now your whole team kind of decided to go in that kind of political slant around bias, positive, negative? Was that a choice that you guys made, or is that something that just kind of came out of the conversations and looking with the data?
Is it okay if I answer it?
Sure.
So, like first, like if we think go back to question one, which was about which topics were like highest bias. We kind of thought that Trump presidency and then politics, it's like more highly based. So when we were looking for the random like bias articles, and we were specifically like when I was thinking about those kind of articles where we can really test our models if there is biasness or not, because like mostly politics is full of bias. I mean, where whatever topic you pick and compare it to politics, politics has the highest bias. So that's why
Mm.
I was
So it
focusing
seemed
on
like a
there, and then
natural
I
fit for you
like
guys.
everybody else kind of agreeing to it. Yes, I kind of
Fantastic. All right. That is Team Fine Print. Thank you all so much. And that team is GL Fadu, Circe Paneke and Julia Porino. All right, our next team tonight is Totally Bias, and that team consists of Ken Klabnik, Randy Overbeek, and Eli Adams.
Okay, let me get that on the screen. Okay. Can you see it fine?
Yes.
Okay. Hello, everyone. We are Team Totally Bias, and we are going to be showing you how we modeled to get textual bias on Wikipedia articles. My name is Eli Adams, and we also have Ken Klabnik and Randy Overbeek. We are all data science graduates in TripleTen. To go over the task, we just have to collect and prepare Wikipedia data, go over EDA, also train a model, and predict the overall bias of the Wikipedia articles we get. And as a bonus, we're also going to go over the types of articles and compare their bias to each other.
Hi, I'm Randy. I'm going to talk about the notebook overview a little bit. We, as everybody else, we are. Hold on a second. I lost the screen here. So as everybody else, we are answering the question of can we detect bias in Wikipedia articles? And so we basically set out to use a pre-prepared data set from Kaggle and natural language processing techniques to detect bias in Wikipedia. And in so doing, we basically obtained that data set, followed a pretty normal machine learning process that included loading, pre-processing, and exploring the data, building and testing a model, and then acquiring Wikipedia articles and evaluating their bias based on that model. And then we're going to discuss the characteristics of bias a little bit at the end. We actually also ended up comparing multiple data sets from the same source, so we'll talk about that as well. You can go on to the next slide. So the first stage, of course, after loading the data is data pre-processing. The data sets provided bias ratings that were rated either biased or not biased. So we turned that into binary numerical data for the model. We also computed a separate feature. The data set included a list of words that indicate bias. So we just counted up how many of those words appear in each sentence, and we used that as a feature for our model as well. The data set included article titles, at least for some of the sentences. So we appended those titles to the articles so that we can get a little bit more content. And then finally, we vectorized the text using PF-IDF, which really just computes a list of scores indicating how important each word is for each text compared to the larger corpus. And so then those numerical encodings were the primary features that we used to model bias.
Hi, I'm Ken. So as with any data science project, it is important to understand what is in your data so that you can analyze it properly. Our data sets came from Kaggle, and they were based on a research paper from a research group that was investigating media bias, and they came up with bias annotated by experts, or BABE. Our main data set is SG2, or subgroup 2, from that paper, which contains about 3,700 sentences from 11 different news outlets and their articles, which were labeled for bias by a panel of 5 experts. You can see the distribution in the chart to the right. The data also contains a link to the source, the topic, and so forth. Additionally, we have a dataset called SG1, which was from the same paper. It contains 1,700 sentences, which are a subset of SG2, and they were labeled by a panel of 8 experts because they wanted to investigate whether more experts or more data was more appropriate. And those 1,700 sentences, in turn, came from a dataset called Media Bias Including Characteristics, or MBIC, which is a canonical dataset about this. Same 1,700 sentences, but the labels were crowdsourced, and as you can see with the chart on the right, it is generally more sensitive to bias than SG1.
Okay, when it came to creating the model, we chose to use a logistic regression model for a couple of reasons. They tend to work best in text applications like this with sparse, high-dimensional linguistic features. So that we expected that logistic regression to work the best. And we did a little bit of preliminary testing with tree-based models and found that they generally weren't as good. You can see that we got decent ROC scores. SG2 dataset was modeled better than the other two, which makes sense because it was larger and it also had a more evenly balanced classes. A ROC above 0.8 seems like a pretty decent score, and it's in line with the models that the dataset authors did. So we felt pretty good about that. And we also found that 47% was the best threshold for predicting bias, at least for these models.
Now we get to the part where we are acquiring different Wikipedia articles. So this code right here shows how we did that. We used Wikipedia API library to fetch the full text of an article by its title. And so if the article exists, the function returns the full body of the article. And then right here, we show how our bias prediction function works. So first we clean up the article text and split it into sentences. Then each sentence it's turned into a feature set using the TF-IDF as we explained how it works before. And then we feed this into our logistic regression model to get the bias probabilities. Finally, we calculate the average probability as the article's bias score and return all predictions so we can analyze it sentence by sentence. And then here, we're going to test it on a random article. So we put Donald Trump in here. So I brought up a random article that has Donald Trump in the title, and it runs through the trained bias detection pipeline. It splits the article into sentences, scores those sentences, and then averages out across the whole article. And we're able to get the score. As you can see here, it's 0.447, so almost half, like 50% bias here. And we also have some other examples of other sentences down there as well.
So the results of our test, when comparing the same model across all three data sets, we get a different distribution of probabilities. X-axis here is the mean bias probability of sentences in a given article. And as you can see, SG2 is there, the bluish one on the lower left runs from about 30 to 55%. SG1 had around the same mean, but was a much narrower band of probabilities, and MBIC was similar to SG1, but was generally more likely to believe that a sentence was biased. For SG1, here's a smattering of results. The most biased article that it found was Islamophobia. The least biased was baseball. Compared to MBIC, which agreed that Islamophobia was the most biased, but it thought that the Russian invasion of Ukraine was the least biased. SG1 flagged 11% of sentences for bias, while MBIC flagged almost all of the sentences for bias. And the mean probabilities were also higher for MBIC, which was as high as 60%. For SG2, which was the larger data set, it felt that the most biased article was gender identity. The least biased article, like MBIC, was the Russian invasion of Ukraine. It had generally a wider range of probabilities, and it flagged about a third of sentences for bias with a mean probability of about 40.8. As for using a lexicon of biased words, most of the sentences in the Wikipedia articles contain 0 words from our lexicon of biased words, so matching that was not necessarily sufficient to detect bias on its own.
Okay, so now let's look at a few bias ratings from the articles in our data set. We comparing the SG1, which was again expert rated, and the MBIC data sets, which was crowdsourced. You can see that there are some differences. They generally agreed on some of the most biased articles, but here we're looking at some of the least biased articles, and you can see the order is quite a bit different between the two data sets and the models derived from them. So that tells us that there is some difference in terms of crowdsourcing versus expert rating. People seem to conceptualize bias, or at least rate bias, in a somewhat different way. Go on to the next slide. Then talking about the main data set, SG2, you can see on the left here we have our most biased articles, and on the right we have a list of our least biased articles. We deliberately chose a sample of articles that were some were more contentious and some were kind of more boring, so that we could get a kind of a diverse range of scores. And you can see that we did get a wide range from 0.28 on the bottom to 0.55 on the top. So we are really getting some differentiation here between different articles. But you can also see on the left that it has some of the more controversial articles towards the top, like gender identity or Fox News or Islamophobia, but it also has some kind of mundane articles like Caterpillar and Euclid. And similarly, if you look on the right, the lower ones also include some controversial stuff like COVID-19 or Black Lives Matter, but as well as mundane things like Nintendo and baseball. So the article titles aren't necessarily obvious giveaways for how bias is going to be assigned, but you can see that there's kind of a range on both sides. But the more biased articles are certainly rated much higher than the least biased articles.
So in conclusion, we were able to collect the bias labels in the beginning. We conducted EDA, as you found in our plots. We trained 3 supervised models. We built a prediction function, as you saw in the Wikipedia articles. And for the bonus question, we were able to look over at the comparison between the articles as you saw in the last two slides.
So, where do we go from here? How might we extend this project? There are quite a few questions that are raised by this. Some of the more interesting ones, how might an article be changed to be perceived as less biased? Can you change the way that facts are presented so that the model will or will not detect them more easily? Additionally, is large language model biased? Large language models are a bit of a hot topic of development and, of course, of discussion. And so understanding how biased their output is going to be important for people working on those. And lastly, is there general agreement on what bias means? Does the public think about bias the same way versus how do experts trained in bias think about it? Thank you very much. We'll take any questions at this time.
All right, that was fantastic. I just want to call out the fact that when you show all of those articles and like the most biased and least biased, on the list of most biased articles was a Wikipedia article about origami. It's a very hot topic.
Yeah,
So
it was
in
a little
thinking
bit
that,
surprising.
like, what is it? I know it's like certain words, but what is it how do you explain that to stakeholders, right? Like if stakeholders were hiring you guys to figure out how they need to write their articles in a less biased way or more biased way or whatever their end goal is, how do you then present to them like, yeah, and here's a good example, the origami article. Do you guys work that in or do you like pull that out as an outlier?
I think it's hard to say without looking at in a little bit more granularity at the words that are used. It might be that there are some specific words that have to do with origami that maybe seem biased in a different context, in a political context, but don't in the origami context. So you might be able to differentiate a little bit that way. But yeah, it's hard to say without digging out a little bit deeper on those articles.
For sure. Now, all three of you have graduated the program, so congratulations on that.
Thank you.
How do you feel like, kind of looking back at your time from your time in the program to the prompt of this project, do you feel like there was any particular sprint that stood out to you, or module that stood out to you in the program that prepared you for this?
Well, it's easy to say that the natural language processing one, as that was very much specialized on this very specific thing.
Okay.
I also personally found a lot of value in some of the early chapters with exploratory data analysis and statistical data analysis, trying to visualize data and ask important questions.
Yeah, definitely any sprint that taught us how to visualize data was probably the most important for this project for me.
And just to be clear, for visualizing the data is not where I'm sitting in a meditation stance and like trying to think of the data, right? Like that's not what we're talking about here.
Yeah, it's trying to turn the data into charts like the bar charts that compare, for instance, which outlets the sentences came from.
Okay.
Yeah, that sort of
Yeah,
thing.
a lot of those other kind of visualizations.
Yeah, it is about processing. Humans can only process numbers so efficiently when there's just a big long list of numbers. But when you can put it in a single image like that, it's a little easier to understand viscerally maybe what's going on.
Love that. And was that in the YouTube channel? Deb said that Sprint 14 is very helpful for this type of project. Would you guys agree with that?
That was the natural language processing one, right?
Great. I
Yes.
was going to ask that next because I was like, and what module was that?
Yeah.
Yes.
Awesome.
Yes, I believe it was. Yep.
All right, Deb, you're in good hands there. It sounds like that's the right one. Well, thank you guys so very much. I really appreciate all of the time, and I really appreciated seeing the articles that have the most bias and the least bias. Because again, I think it is easy for us to think of bias in those senses of like political stance, but you guys also highlighted that there can be those places where we need to dig a little deeper, where there's origami or Nintendo, and like, what is it about those things that makes them biased? And I think that would be really useful for a business perspective. So I appreciate you guys showing
Yeah.
those two charts there.
Yes, there are people with strong opinions about all sorts of things.
That is so real. All right, that is totally biased. They're getting lots of shout outs in the YouTube channel, so make sure you vote for them if they are your audience favorite. That team is Ken Klabnik, Randy Overbeek, and Eli Adams. And then our last team for the evening is the Data Dudes, which I just love that name. Big fan of the alliteration there. And that team is Victor Kliufinski, Ahmed Tayeb, and Rawa Youssef.
Hello, hello. Let me share my screen and put it up. Can you see the screen? Okay. So, hello everyone. My name is Hamed. We are Team Data Dudes. In this May.js code pudding, we've been working on detecting and quantifying bias in Wikipedia articles using NLP techniques. Let me go to next one. Actually, we took one of the internet biggest knowledge hubs, Wikipedia. But here is the twist. We are not reading articles this time. We are investing them. So we trained some very smart model, logistic regression, cat boost, and even BERT to detect hidden bias in Wikipedia articles, sentence by sentence. Think of it like a true detector, spotting where things sound fair and where they might be a little too biased. From political or politics to pop culture, our model scan it all. And now we have the model. So our team, like I said, Data Dudes includes myself, Victor, and Rawa, where Victor and I work on the data preparation and EDA, and Rawa done the modeling. Regarding the challenge and complexity, bias can be solved either in a word choice, sentence structure, or even the presence of images. And our goal was to build a model that could identify those signals, right? We work with the data set of over 2,000 articles labeled as either biased or unbiased, which we use as a proxy for detecting biased content. Victor will walk you through the pattern we uncovered during our EDA, and Bravo will explain how we model, the problem, how the model perform, and what insight we gain. Let's dive and see how it works. Victor, please go ahead.
Hello, my name is Victor, and I'm gonna start. So I'm gonna start. What it is? It's this EDA. So EDA means, and we're gonna take a close look at the data to understand it better. So it helps us to understand what's in the data actually, and what else we can add, and what's important. So we clean the text. We actually remove the symbols, and we use like spacey and wader to check the sentence structure and emotion. So we use spacey and wader. So the wader is you can find like an emotion or tone in text, and spacey you can just like clean and understand what's the text. So biased articles are the ones that sound more emotional actually, and often like using political or strong sentences and languages. So the next slide. Probably you're gonna ask us, how did we prepare the data? So we used like 2,094 labeled articles with data and text features, and we use like the same tools, Wader and Spacey, because they help us to clean the data using NLP. So NLP, it's natural language processing. So the next slide, please. So we looked at 2,095 Wikipedia style articles, and 62% were biased and 38 were unbiased. And all of these articles sizes were actually different. And some of them just had like one sentence, and the others like over 5,000 words or more even. So, but the most of the articles were very short, like just 300 words or maybe less. And biased articles use like very strong words like election and presidential stuff, and unbiased ones use just like natural words like state or media. And biased articles also had more emotional tone and based on the sentiment scores. That's it.
So I will take it from here. Thank you for Victor and Hamid. So we tested a variety of models, including logistic regression, XGBoost, CatBoost, and BERT, using both TF, IDF, and transformer-based encoding. And if you notice, we used supervised and unsupervised training models. So why we added BERT? Because it captures deep context, helping identify subtle implicit biases that simpler models might miss. However, CatBoost gave us the best overall performance with 77% accuracy and 85% AUC, making it our top choice for sentence level bias detection. Next, please. So once we trained, we used the best model to assign bias score to full articles by averaging the predict bias probabilities across sentence. This method let us rank articles and visualize bias trends by topics. Like what we see, 62% of articles were found biased content. The most biased topic included science and economy and social issues. Next, please. And here we will see that the latest thing in the bias, it was like impeachment with 58%, comes after that Democratic Party 65%, then religious 66%. Next. We had many limitations in this project, but as you see, there are many, but the most important three, it was labeling challenging. Sentence level biased labels were passed on a heuristic zero-hold Vadir-like logic, which might not perfectly match human judgmental. So we validated model predictions manually on a subset and parameterized interpretable models like logistic regression and CatBoost. And we had data in plus natural sentences outnumber biased ones. We used stratified sampling and F1 score as a C metric to avoid misleading results. And we had one of the most limitations that we faced, language scope. Our model only covered English articles, and we propose using multilingual transformers to expand the global content. Next, please. So we put some recommendation for Wikipedia, and we think that using AI to assist editors deploy our CatBoost based model or BERT pipeline to flag biased sentence during editing in real time. And real-time moderation tools, build interfaces that show bias scores while writing, helping contributors stay natural. Focus community reviews on risky topics, categories like social issues and science that showed high bias. This needs more oversight. Incorporate sentiment into flagging systems. Since traditional methods like view or edit do reflect bias, text-based model offer a more accurate picture. Expand to non-English Wikipedia. Using multilingual NLP models to ensure fairness and neutrality across the language editions. Final takeaway, our approach offers a scalable, interpretable, and accurate system to help Wikipedia maintain its core value, naturality. By combining CatBoost performance with BERT context sensitivity and translating insights into editorial tools, we bridge the gap between machine learning and public trust in knowledge. Thank you for listening. And if you see that we deserve it, just vote for us.
I love that. Get that plug in there. Vote for us. All right. Really great presentation. I really appreciate so much at the end where you guys have the considerations of like, here's what you can do with this data, Wikipedia. You guys could be using AI to do this or publishing the transparency reports. I think that would be so cool, right? Like just seeing how much all the teams tonight have been able to show us what amount of which articles are biased and using biased language. they could totally do that on a grand scale. And that would be super helpful so people can stay informed, but also, be more informed of what biases may be lurking in the Nintendo and origami articles. Notice I'm staying away from those political articles like the plague. Okay, so let's talk to Rawa real quick. So Rawa, this is not your first time around. How is it this time around?
Okay, so this is my first project that I feel more responsibility to give all of my experience for my coworkers. I tried my best to show them what I got from the last two projects and just guide them what did we miss in the last two projects and what we can improve this time. And I was trying to how much like I remembered when I was in the first project that I was just watching more and I don't know what to do. So I was trying like talking too much about it and I feel that, but I felt like I wish that I had the same. So I was trying to be this meeting point with them that, hey, it's going to be easy. It's not difficult. You already have the skills to be here. If you are not, you wouldn't be here. And we did a great job together. My team workers, they were really good. And we were always open to cooperate together to make it happen.
Oh, that's great. I'm really glad to hear that. I'm also glad to hear that you found the feedback from the coaches really helpful in coming back each time and improving on your projects and presentations each time. That's really great to hear. All right, Ahmed and Victor, let's talk about how you felt like the project went. So in terms of like working remotely with new people that you guys have never worked with before, trying to coordinate all of these pieces, time, so short. What are we going to do? How was it for you guys?
Victor, you go first.
All right, so actually it was my first project, like first CodeJam project. So I didn't know where I need to start, and like where I can find like all information about the project. So I was very worried about all of this. But I found like very amazing people like Hamad and Rawa, so they helped me a lot. They helped me like with the small details. So it was amazing actually. And I'm very
Great. That's wonderful to hear. I'm really glad. I know that at the briefing, a lot of nervous people, especially when we start going over the prompt and the data. There's a lot of nerves that are in that briefing room. And so it's amazing to see how much confidence all of you gain from the briefing to 5 days later when you're showing it off,
Yep.
Exactly. I think for me, I've been in technology for a long time. I had a lot of experience with the remote work, but having a limited time to deliver a big project, it was a new challenge for me. And I'm so glad that I had Victor and Rawa in our team. With Rawa's lead, we could able to plan accordingly, deliver it, and honestly, we were able to finish our project even earlier than the deadline. So
oh, snap.
yeah, so it was good experience. Like I said, if you want to do anything, you can do it. Just start doing that and deliver it. So I joined with the empty cup. I'm glad that I joined TripleTen because I'm getting a lot of different experience that helped me to grow. So this group and this team helps me a lot during this couple of days, and I'm so glad that I was part of this team.
Oh, I'm so glad to hear that. That makes my little teacher heart so happy. All right, that is the data dudes. That is Victor Klinfinski, Hamed Tayed, and Rawa Youssef. Okay, that is all from us tonight. Those are all of our teams. So from all of us here at TripleTen, this has been the May Data Science Code Pudding presentation. Thank you so much for watching. Thank you, Deb, for watching. And please make sure that you leave a comment if you're watching us on replay or if you're watching this on YouTube in the comments below, which team was your favorite so that team can get your audience vote. If you are a student of ours, you can vote in the Discord channel where you will see the poll after this. The results and the winners will be announced on May 14th in Discord and in all of our socials. It certainly takes a lot of teamwork to do all of these projects in 5 days, and it takes a lot of teamwork with great people to work on getting all of these presentations out to you from TripleTen. So special thanks to everyone who helped organize this code pudding: Daniel, Camilo, Alyssa, Elena, Olivia, Dennis, Anastasia, and of course my cat Sharkbait. Thank you again for all of the participants presenting your work today. I really am just always so impressed with your perseverance and your courage in coming out even when it is uncomfortable and you're new and you're feeling all the nerves. You guys do an amazing job every time of taking just the boring numbers on a page and really telling a story with it. So thank you so much. Again, my name is Tiffany Hall. You can find me at Tiffany Codes on Instagram, and you can find my cat Sharkbait trying to put the hyper in his hyperthyroidism. Thank y'all for watching and have a great night.